So in the previous sections, we talked about the hardware. We talked about why we chose the APRX software for the iGate functionality. And we also talked a little bit about the flow of the logic behind the APRX software from a perspective of the iGate in my application. And we covered this particular slide to be able to beacon on a recurring basis both to the APRS-IS directly and through the RF using the via ARISS parameter. So we also talked about the filtering of incoming RF packets to only those that are digipeated by RS0ISS, and then iGating them to APRS-IS, and then digipeating them back to RF. The digipeating back to RF, I'm going to reserve that for a phase 2 for now. What I'm going to work on right now is once I find the digipeated packets by RS0ISS, I'm going to iGate those packets to APRS-IS. And we also covered the notion of the source destination in our previous sections. So in this section, let's talk a little bit about the how-to portion of the aprx.conf file. And let's get started. So I have my connection to the Raspberry Pi pulled up here. If you go to the /etc folder, there's this file called aprx.conf file, which is where you would have all the configuration details for the APRX software. I have a notepad pulled up here with the aprx.conf file. So basically, I'm going to walk you through what it is in this conf file that defines the APRX software's behavior. So first things first, you would define your location and your call sign that you will use for your iGate. So in this case, it's N0AGI-10, my lat long location using the mylock variable and the mycall variable for the call sign. Followed by, I'm going to define the connectivity details for my APRS-IS server. In this case, I'm connecting to first.aprs.net. The 14580 is a default port that you want to connect to, and then you need to provide your own password that you got for your call sign. Followed by which I'm defining here the interface like we talked about in our previous section, which is this one here. We are defining the RF interface, and we are saying my RF interface is hooked up to the /dev tty ama0, which is my tnc-pi at that baud rate and other parameters. Followed by, I'm identifying the mycall as the alias that is going to be attached to this interface, so that every time I reference my call variable, I'm actually linking that reference to this interface. So since we're going to be transmitting through this radio interface, you want to include the tx-ok variable equals true. The next section here talks about the logging information. You're providing the path to the log files, nothing fancy there. And the next section here talks about the beacons. The beacons is the section where you define which beacon you want to send to which endpoint. So let's talk a little bit about this section here. So I have a beacon section set up here for the APRS-IS server. I want a beacon every 15 minutes cycle size, and the beacon parameters. The beacon parameters includes things like the symbol. In this case, I believe it's a satellite icon. I'm going to reference my $mylock variable, which is really just that, my location information, and the comment variable, and include my comment in there. There is a limit to how many characters can be presented in the comment variable. I don't know that off the top of my head. So this section defines the beacon that you are sending to the APRS-IS software like we discussed here. So basically the beacon going in through this channel directly through APRS-IS. The next section of the beacon is for the radio. We talked about sending once every whatever 30 seconds, 15 minutes, half hour, whatever be the case, send out a beacon to the RF and using the via tag in it. I'm identifying the beacon mode to be radio here versus beacon mode to be APRS-IS here. Radio references to this interface which is attached to the tnc-pi, which is my radio interface. So basically when I beacon out, I'm going through this interface and then the beacon gets sent out through the radio. I'm including essentially the same details except for some additional parameters. I'm including a destination call as CQ. It could be anything here really, doesn't really matter. But I think for clarity, I'm just including it to be CQ. I'm including my symbol followed by the via ARISS parameter so that I get distributed by the RS0ISS followed by my location variable and my comment. So nothing fancy there again. So what this is going to do for me is it's going to first off identify that my radio interface is not only an input or a source of packet for me, it is also a destination for me because I'm enabling transmit through it. And then it's also going to help me set up a beacon to do once every 15 minutes to the APRS-IS server directly, and then a separate beacon go through the RF interface. I'm including the via ARISS tags as part of that beacon. So that's really it. I think one thing that I'm missing, I'm not including intentionally as part of this is the filter we talked about in the previous slide. We said we're going to filter down the incoming packets and filter only to those that are RS0ISS, and then if found, then do the iGate. This is still fine, but I believe the current version of APRX software has some limitations to the incoming RF packet filtering. I got to do some more experimenting on that. So I'd like to test that out first before I did a video here. So that's really it. Now let's jump on to a real life example of how this whole thing's coming together, and we'll close this series of videos, and we'll talk soon.